Thank you, everyone. Some of you might know me from like my day-to-day work with open source software and sovereign tech agency, but I just wanted to say that today I'm here more on a side quest. This has been part of a fellowship I was doing under the SOAM, called SOAM, Refund Our Digital Future. And the goal for me was to explore an area where I'm not, I've always been interested in, I thought was really important, but haven't had the chance to dig into before. Another thing you might not know about me is I'm a computer engineer by training. I actually studied embedded systems, but I never worked in the field. And I think after you'll see also why, like what are sort of the barriers that stop lots of people from actually pursuing a career in hardware and silicon. So where do we start? Every public AI project, every sort of climate sensor effort, every medical lab device has this hidden barrier. Like the tools to design the hardware and the factories to manufacture it are controlled by a small number of people. And today I want to attempt to sort of explain why I think this divergence happened, like why software became open in the commons and hardware didn't, and what sort of like the structural reasons behind it. And it's also more of a speculative exercise, so I invite you all to also speculate with me, ask me questions. If you think I made a mistake in my analysis, please let me know, because that's how I want to, I'm sorry, I'm having, yeah, it should work now. Yeah, so let's start. So this is a chip under a microscope. As you can see, it's an incredible feat of engineering. Like those electrons, like often run in some of those newer systems, run closer than like a packed U8 on rush hour. And everything we talk about that's digital, whether software, whether it runs on your computer, on someone else's computer, everything ultimately, I think, needs to run on one of those things. So in a visceral way, it represents the physical manifestation of like everything we work on. And for something that I think that's important, I don't feel like we talk enough about how those things are produced and how, yeah, sort of the structural barriers there. And this is what I want to explore more here. So the elephant in the room, open hardware does exist. You can design boards, you can share schematics, you can build with open components. But the infrastructure underneath, so the tools to design the chips, the factories to manufacture them, is all proprietary. And I think there's sort of like some, what I call like the silicon boundary, like this is where like all the openness stops, and like underneath that you're forced to use someone else's chips made by someone else. So if you look at the design tools, or EDA, 74% of these are controlled by 3 companies, so Siemens, Cadence, and Synopsys. And if you want to have a seat to use one of those tools, it's somewhere between $500,000 to $1 million. Like it's a lot of money. So actually, like even I've heard stories of like many people who work on designing chips. They would use whatever open tools that exist up to a point, and when they need to go into production, they would have one seat that they would all share to actually turn the things into production ready. This is what the inside of a fab looks like. It's again, it's a very expensive place to be in, and for the machines inside those fabs or places where people make chips, one company essentially has a monopoly on the most advanced technologies, what are called lithography tools. It costs, like some of the most recent ones cost up to $318 million just for one machine. So if you compare that to the budget of an average research company, that's like 7 to 8 times the entire budget. So hardware infrastructure essentially functions as a private utility with no public alternative. And you can have the best ideas, the best designs, you can be thinking of the most urgent social needs, but if you can't access this utility, you don't get to build what you want to build. Let's go back to this divergence that I'm talking about. So this is something we're familiar with. Software, we have open protocols, open tooling at the basis. We have compilers and runtimes in operating systems that are open. And then on top of that, we build all these open products and services, or even closed ones. It doesn't matter. They all use the same infrastructure. And everyone gets to participate in this at every level. But if you look at hardware, sure, the research, the design ideas might exist. You can do them. But once you want to move to production, first you hit one gate, which is the design tooling and all the verification tool chains. And then even if you get past that, then you have the PDKs, so the production development kits. So that's what that's like the whole chain that turns like everything from a design to an actual something that could be produced. And then you have access to foundries. Actually, if you don't already have an established relationship to a chip foundry, chances are you as a newcomer of getting a chance to even make your design chips is you'll have to wait a very long time and pay a lot of money. So essentially, participation is blocked by all of these different gates. So in software, we learn to share the parts that no one wants to reinvent twice, but in hardware, for some reason, we never did. So what are the things like these theoretical chips that we couldn't design? So if we think about like custom, like all systems on a chip for climate purposes, if you think about purpose-built medical silicon, if you think about sensors in agriculture, if you think about processors that are resilient for disasters, which we continue to have more of day by day, all of these are, you can't do them on the silicon level. You can use open PCBs, you can use Arduino, open hardware products do exist, but ultimately you are locked into the drawbacks of using these systems, and you can't design. You're locked to these like consumer grade electronics, and you have this barrier where you can't actually build what you really need at the level that you really want. And I think that's really like just a cap on innovation. So the tragedy is not expensive chips; it's the chips we never get to build, I think. So if you want to look a bit closer about sort of what the barriers are that I see here, so first of all, you have this capital intensity. So these tools and machines that we talked about, what ASML has or what the EDA tools have, those didn't come overnight. Like those have thousands of engineering hours put into them. And that's something that's beyond the capacity of a volunteer community or what a grant cycle can sustain. On another level, there's an institutional vacuum. So there's no permanent operator or there's no career path for maintainers that want to pursue this on the long term. So more often than not, you end up with knowledge dissipating between different funding rounds that have tried to address this issue before. And then finally, you have this revenue dynamics, so which often heavily favors the commercial revenue versus the social benefits of hardware. And obviously, since we're at an open source conference, the question stands is, can licensing fix any of these problems? The answer is no. Better licensing can't finance a tool chain that requires thousands of years of engineering years. If we want to really address the issue of closed hardware, if we really want to address hardware infrastructure on that scale, we require a sustained coordinated investment at scale where community governance and licensing alone just aren't able to address. And I mentioned existing efforts, and I want to point to two that are important in this context. So people talk a lot about RISC-V, so it opens up sort of the instruction set architecture, really important work. But you still, like if you want to use RISC-V, these days you're mostly dependent on proprietary EDA and restricted foundry access. So while the instruction set is open, the infrastructure is still a bit closed. And another initiative I want to point to is Open Road. That was a DARPA-funded project to open source a whole production development PDK toolchain for chip design. And it did manage to achieve real progress towards reducing the barriers. But it's a grant-funded project, and obviously grants run out at some point. And it didn't really solve that sort of last-mile problems. How do we get this research into something that can actually be used by people everywhere? So I think the thing that's actually missing, It's not the knowledge, it's not the will, it's an institution. It's a new kind of institution that I want to speculate about with you all here. I call it the open hardware infrastructure works. And the way I see it, it could be a permanent institution employing thousands of engineers building and operating this hardware infrastructure as a commons. Because right now we compete on who can afford the tools, not who can build the best tools. And I think that's obviously something that we need to fix. This is Dutch dike, so it's water infrastructure. Those things are big, they require a lot of effort to build, and obviously, again, you can see the parallels here of like big infrastructure project, too big for one person to handle, too big for a small village to handle, but if everyone gets together, we can build something big like this, and we've been doing that for hundreds of years. And there's other precedents, I think. I won't go through them one by one, but I think it's important to note institutions like CERN, companies like the Autobahn GmbH, Airbus as well, NASA and ESA are other examples of like big things that we decided are big enough that they're worth having their own institution for. And a little teaser for later. So water boards were mostly funded using bonds, like public bonds. So this is why I think like a project like this, which is infrastructure, it should be funded like infrastructure. So I'm not going to go through this in detail. I'll share a link at the end. But the gist of it is, instead of having to wait until all those smaller efforts build up to have some momentum, which might never happen, we want to give this project a bit of a runway. And that's why like government-secured long-term bonds gives you this capital that you can use to invest to build those essential building blocks. And once it's up and running, it can switch the revenue mechanism from extracting rent from licenses and tools to actually providing services that are useful. And that way it can fund itself, it can pay back those loans, it can pay back those bonds, I mean. And this is essentially also how those water board bonds that have been working for hundreds of years work. I also thought a bit about governance. I think something like this should have more of a tripartite model of governance where you have the public funders on one side that can help prevent it from being captured. You have the public interest represented to make sure that it stays on course, it remains on that social mission, not too driven by commercial interests. And then you also need to have a technical community on board to make sure that it also stays on the technical mission. So this model would help sort of prevent any one interest from being overrepresented or anyone from capturing the governance of it. So, and I'm gonna pause here because that was the end of the speculative thing. I wanna preface that I still think there's a fundamental problem at the layer of this that I haven't addressed through this fellowship, is that even open hardware still runs through mines and fabs. There's incredible harms that comes from those practices, extractive practices that that are hidden underneath all those layers. And I haven't had the chance to explore to this. I don't think this institution is also going to solve this. But if you're interested in talking about this, I'm having a workshop at Cables of Resistance to talk about more this area of it, the mineral extraction, the labor exploitation, the e-waste. I welcome people, like it's not going to require any prior knowledge, but I welcome people to come there and join me in this workshop and help me think through some of that aspect of it. If you're interested in the presentation, you want to see it, you can also go to ohiw.tarakiyee.com, where I have the presentation essentially in a mini-site form. Thought it would be better than giving handouts or something like that. And that's it for my presentation today. So do we have time for maybe
Yeah,
questions?
absolutely. Yeah. So round of applause for Tara. And according to my watch, we've got even 15 minutes of Q&A, so let's have a discussion going.
Okay, thank you very much for this talk. I guess you're not really honest because you're talking about the high end, But on the low end, there's so much going on in terms of open hardware. I mean, we are talking about Sky 130, GF 180, eFabless is even alive again after with wafer space. There's tons of EDA software available, and Open Road, by the way, is a very good project in my opinion. So it doesn't deserve being called, let's say, a failure.
I didn't want to imply that, just to be clear. I'm a fan of it, that's why I mentioned it.
I think you didn't do so, but it's just, let's say. There's actually a live community available. So there's a conference in summer in Ljubljana, the Free Silicon Conference, which deals exactly with that problem. There are multiple foundries around. One of them is, let's say, 70 kilometers east of here in Frankfurt an der Oder, who offers services where you can, let's say, have, I don't know exactly the price, but like it's a few K affordable, and there's funding available by the government. So there is a exciting development in the last 5 years. And I'm one of the tool maintainers of one of the tools, K-Layout, if you know it, maybe. And I think it's worth explaining that there is such a ecosystem available.
No, definitely. And this is actually like maybe, if we're also being honest, like one of the hardest parts about doing this is because I didn't want to skip or go over like all the important open hardware things that are existing. I think they're incredibly important, incredibly valuable, because also like otherwise, like we would be starting from way behind if we didn't have those efforts. I think those efforts should be the core focus of an institution like this, of supporting them, creating an ecosystem for them. But the key point I was trying to make with that slide is we have been having those efforts for a while, but if you look at the scale of the problem, if you look at how far commercial hardware or commercial hardware production is concentrated and proprietary, we need something we need all those efforts to be more and on a bigger scale, and we need something to anchor all of this work and make it more permanent, if that answers your question.
Nowadays, it look like people do not even cross their minds about that, because there's this feeling that the materials, it's already established field. Where do you think it would be most beneficial for societies if governments or specific, not by nations, but for a specific, not monopolistic way, would be more beneficial for society itself, the worth to invest in on hardware?
Sorry, can you repeat the last part?
Where do you think it would be more public interest? Where would it be more valuable for societies to make this big commitment and investment?
I mean, I don't know if I'm being too tunnel vision, but for me, like I think, considering, the climate disaster that we're in, like that would be where like my focus is, and I think that's might have shown in some of the examples I brought up. I'm not a technical solutionist. I don't think technology will solve everything, but I think we rely a lot on technology, and if we want to have a sustainable future, if we want to have a better future for our planet, then the way we make our technology should reflect that, and the way we make our hardware should reflect that. So, and there could be certain applications where, if that was the goal, like if the goal wasn't to make like the most efficient, fastest chips, the goal was to make the most ecologically sustainable chips, then that's where I see like the most benefit of something like this happening. But you can also extend this also to other areas of concern as well. Like I think the fact is I think there's too much focus on the commercial interest, on the efficiency, on the speed, on making things smaller, rather than on looking at the big picture, looking at the public benefit, looking at the public interest.
I was wondering, speaking of public interest and sustainability there, the first thing that came to my mind was the lack of supply chain knowledge and the actual hardware already. Like just for an example, maybe everyone in hardware uses solder, but Yeah, I don't know if you know the company called Naga that has actually a supply chain for their solder, and they couldn't dwindle like down where all the little stuff came in. But that's what they're there for, that is the purpose of that solder, to have supply chain information. So the idea with open hardware, is always a noble feat, but there are these kind of problems that are part of the discussion when we want something open and sustainable, but there will be these little walls. How can we cross them? Or even if we want to cross them, how can we have it at least to a point including these efforts, but at the same time acknowledging that it will also not be fully sustainable, ecological friendly. Like you can't, I think at this point, like what Naga has already shown is you can come from the good side with all these efforts, and at some point you have to face defeat because there will be mining and there will be, and then how do you weigh this against the public interest if you want to be on the good side? So that's my question.
Yeah, and I don't know if I can speak directly to this, but I think that's where like maybe the governance issue comes in, the governance part of this comes into play, like, because I think ultimately it's not only technical problems, there are social problems as well, there's people problems, and that's why like I didn't suggest like a board of just like technical community or a board of just funders. I think having the public interest represented in a way, and I don't want to go deep into how to do that exactly, because I think there's multiple ways to do that could work. But I think having that represented in a fair way would help us come to grips with that. On a more fundamental level, that's also why I'm doing this workshop, is because, and again, like this is me being totally like maybe honest and vulnerable here, I don't know if there's an ethical way to make hardware. I don't know if there's a sustainable way to make hardware. I don't know what that means for me or for the world or for everyone. And that's part of the questions why I want to explore here is there a path towards it? Or if this is a harm we're willing to accept, how much harm are we willing to accept and to whom, and what that means, just make that a bit more explicit maybe. I think like that's also like fundamental of how we treat hardware in our lives. Like you almost never see chips the way like you saw in like the first slide. Like we always hide them behind like these fancy, nice, clean looking things. But when you look at them, they're actually complex and brilliant and all of that. And I think that's why, like, for example, like at home, like I have like my tower desktop with like a side screen. I used to have for my phone like one of those covers that show like the chips on it, because I love that. I love looking at that. But I think the downside also of like not looking at the chips is also that we're hiding all the harms that come from them and hiding all the uncomfortable truths maybe. So, and I think like that's not good for society in general.
Thank you. First, a comment. I think what you're saying about making things smaller and faster, there's another side benefit to that, is usually it makes them lower power. So, for the same amount of work, we can get a lot less environmental effect from having things smaller. But my main point was I get the impression that the issue is that there's a chasm between doing wafer sharing with open source software and moving to sort of low niche production, like a medical chip where you might need 1,000 or 10,000 or something like that. And the masks are incredibly expensive and the times are so long. So I'm wondering if there's any attempt to maybe at first, am I wrong? And secondly, is there a way to attack that particular problem? I get the impression in China it's relatively easy to make lower end chips in small quantities. They seem to be doing it all the time, so many fabless companies.
And certainly I think, again, like this was also like a speculative exercise. It invites us to think about the whole thing by imagining what like this big $1 billion institution. Now, I don't have $30 billion, and I don't know if any of you do, but probably like the right answer, like the realistic answer, the realistic policy choice would be somewhere in the middle or somewhere closer to building on the efforts that you've both explained. So yeah, I mean, I would say like, yeah, exactly. Like, but for me, this isn't maybe about like trying to tackle like those small problems, but looking at it more from a what does this mean for society and how we, and using it as a way to investigate all those problems with hardware and making it more visible, at least, I think.
Please, round of applause for Tara.